Hey guys, I'm Hermann Singh. Right now I'm an engineer at Honda R&D and also CEO of a startup called Spot Shark. So I wanted to take some time here to talk to you about some hardware hacking. And hardware hacking has become a huge new thing. And with technology nowadays, technology revolutionizes the way that we live our everyday lives. And one of the biggest things now is the open source hardware community. So there's a lot of cool things going on, and I'd like to share with you. So why do we hack stuff? Why do we mess with stuff? Because it's fun. It's nice to take things apart. I'm an engineer. I love to break things and try to put them back together. It's problem solving, thinking that motivates us to solve these problems that we have, and that's why we do it. So I've kind of set this up into like a little step-by-step process for people who have not had the hardware hacking experiences and try to get you guys into it. So step one is to buy a microcontroller. These things are cheap. You can get an Arduino for less than $30, and you can do a lot with them. There's other options like the Beagle board, but they pretty much offer the same thing. You can use this open source platform to easily control LEDs, read sensors, turn lights on and off, and all sorts of different neat little projects that even kids now are doing these days. Step two is to buy a Raspberry Pi. For you guys, this is a Raspberry Pi right here. It's about, this is in an enclosure, but it's about the size of a credit card. It's a 700 megahertz processor, and it's available for $40, and it can decode HD video and uses 5 watts of energy. It's an amazing piece of hardware that it's available, it's open source. Anyone can mess with these things. And they're great tools. They're your arsenal for hardware hacking. So why the Raspberry Pi? I talked about how it has very low power consumption, it's cheap. The Arduino as well is so cheap that it's almost hard to say not to buy these things, at least as someone who's into all the tech field. So I think the next step is to find a project, and a lot of what you're going to learn is when you actually committed yourself to doing something. And whether it's, you build a useless box, which is, I think it's hilarious, or if you build like a RC car, or even just, I built a data logger for my car. Something that actually, affects you and that you can relate to and feel really accomplished when you fulfill this task. Step 4, gather your resources. There's so many resources available online. Arduino has a lot of open source libraries that people have created, user libraries, there's forums, there's tons of places where you can go and get these resources. SparkFun is a great resource for shields for Arduinos, which are pretty much just like add-on packs to do stuff that make it super simple, plug and play. The next step is to actually make a prototype. I think this is the most fun part. Sometimes it can be frustrating, but when you actually get something finished and complete, there's nothing that can replace that sensation of, yes, I've done it. And it's fun. It's fun. You get to actually build something physical. Step 6, learn some code. There's some great resources available. Like I said, Arduino has their libraries, which make it really easy to do a lot of powerful things with almost no programming skill required. It's incredible. Code Academy and Code School are both great resources to learn how to actually use these devices. You can start writing code immediately in a nice interactive, graphical format, so that way it's, you become accustomed to actually thinking in the way that you code. Once you've done what you wanted to do, you show it off. Show your friends. There's nothing more fun than saying that, hey, I built this data logger and it's working and it's doing this, and it's a great motivator to fulfill you to do this again. The next step is build an interface. You've done something. Okay, that's pretty cool. Now try to make it such that you can have more possibilities to use this. So I've done some bits with Raspberry Pi where you can actually create web servers, and then you can and then you can you can pair up this microcontroller and access it anywhere in the world because it's on the internet. It's amazing. You can start controlling stuff around the world, and you can do this we've only spent like $70 in parts so far. It's amazing. Step 9 is reflection. So what have you done? And have you actually solved your problem? Can you make it better? Is there something else that you want to do to maybe pivot, or something else that you might have found along the way that may make it into another idea or another project? And then you can take a step back and see how all these things are relating. And it's like I said, you could be controlling your car from the internet on your phone in your like in the parking lot. I can turn my car on, or like you can be controlling your HVAC from your phone. I'll get into later some of the cool examples, but using your resources, if you want to start making this into a real thing, there's a lot of great things you can do, like put it on Indiegogo or Kickstarter, and make it into something big, and use these resources. You'll see that it's blowing up with just all these hardware devices. You have the whole 3D printing. You have a bunch of Arduino stuff, and there's a growing amount of Raspberry Pi. So, what can you really do with this thing? Like I talked about, you can control these things from wherever you want. There's some really cool things that I've seen in the past year. One of them is Lockatron. If you guys haven't heard, it's pretty much just like a wireless locking device for your home. And you can control it from your phone. You can give privileges to other people, your friends, family, whoever you want, or if you don't want to give them privileges. But anyways, it's a great example of what is it really? It's a microcontroller plus a web server. It's just those two components, and that's really all it comes down to. Nest, like I said, you can control your HVAC from your phone. What is it? It's a microcontroller with a web server. You can control it from wherever you want in the world. And Oculus Rift, I love this thing. It's making virtual reality real. And what it's doing is basically just a way of graphically computing your environment and creating your surroundings more interactive with you. It's really just a bunch of sensors and processors. It's the same thing. So you guys see a trend. So you can do all this stuff. And the reason I showed you all these examples is because the hardware is there for you. So you can make these projects. It's not hard. You can go online, find resources. You'll probably find people who are doing the same stuff or similar things, and you can use that. It's really incredible what you can do nowadays. So, closing thoughts. Technology is pretty insane. I mean, it changes so quickly, and even just these two devices will be outdated in the next year. I mean, it's incredible what we've seen with our phones in the past few years. So keep in mind that technology is enabling. It allows you to use it, and the open hardware community is allowing you to just have all these devices in your own home to tinker with, to mess with. And then lastly, I'll leave you with a couple quotes from one of my idols. And I wanted to remind you guys that failure is part of innovation. And if you're not failing, then I don't think you're really learning. And you need to keep and persist and innovate, so that way you can create something beautiful.
Great. Thank you.